Okay. Continuation of the transient problems topic. We are solving so many problems in the transient analysis since last few lectures. So continue to solve some more problems. So in this problem, if you look at switch K opened at t equal to 0, the switch K opened at t equal to 0, find Vk. Vk means voltage across the switch is indicated with Vk. So Vk 0 plus and Vk prime 0 plus. So these two questions we have to answer. So since they are asking at 0 plus, as usual, draw the equivalent circuit at t equal to 0 minus. 0 minus is always steady state. And here switch is what, closed or open? Open at 0, so closed at 0 minus. Therefore, switch is closed and the steady state inductor is short. And here there is a capacitor 0 minus steady state. Na? So steady state it is open. This is 2 volts. So this voltage we call it as Vc0 minus capacitor with this polarity. In the inductor, we call current IL0 minus. Now looking at this circuit, we need to find IL0 minus and Vc0 minus. So here across the capacitor, the switch is closed now. When the switch is closed, no scope for this capacitor to charge because current will flow in this loop. Through this closed switch only current flowing. So capacitor cannot charge. Therefore Vc0 minus is 0. Then IL0 minus is 2 by 1. 2 by 1 equal to 2 amps. So 0 minus we have done. Next at t equal to 0 plus. We solve so many problems using this concept. We are drawing equivalent at 0 minus, 0 plus, infinite, and so on. So by this time, you should get confidence. So 0 plus. So 0 plus switch is open and replace the capacitor with the voltage source. Replace capacitor with voltage source, but what is its value? 0. And the inductor replace with the current source. Current source of 2 amps. One ohm, 2 volts. So 0 plus which is open, inductor current source, capacitor voltage source of 0. Now what we have to find in this? Vk, Vk 0 plus, Vk. So in this, when switch is open, this voltage is indicated with Vk. So I am calling Vk 0 plus this side minus, this side plus. So as usual, started positive, go to negative. What you get answer? Vk 0 plus equal to 0. So that is the answer. Vk 0 plus is 0. Next we have to find Vk prime. So dVk by dt. Okay. For that we need higher order, like a first order derivative. So compulsorily we have to form mesh equation or differential equation after switch is open. Because 0 plus now we are interested after switch is open. So after switch is open, go through this capacitor. Go through this capacitor. Therefore, at t equal to 0 plus, write the mesh equation. So how to write mesh equation? 2 is equal to voltage across capacitor. That is 1 by C. 1 by C. We are going through capacitor. So capacitor value 1 by 2, inductor of 1 Henry. So we have capacitor of 1 by 2. 1 by C integral. Initial voltage anyway 0. So I can take it from 0 plus 2t and assume current of I of t dt plus LdI by dt. L value is 1. Then di by dt plus R into I. R is 1. So I of t. So this is the mesh equation. No. He is asking dVk na. So this mesh equation sufficient. This whole not necessary. This is not necessary. Depending on the question, we have to decide. Vk prime na. What is the equation for Vk? Vk of t. Vk of t is nothing but 1 by C, 1 by 2 integral 0 plus 2t I of t d. Now we are looking for dVk. Differentiate. dVk by dt is nothing but 2 I of t. But what is asking? Vk prime 0 plus. That is nothing but 2 into I0 plus. So what is I0 plus? I0 plus. So 0 plus which circuit is? This is the valid circuit at equal to 0 plus. So 0 plus, this switch is open. Current flowing through this. So what is the current here? 2 amps. So what is I0 plus will be 2 amps only. I0 plus is 2 amps. So this is nothing but 2 into 2 equal to 4 volts per second. 4 volts per second. This we have done. If you want to, anyway, this equation written, we can also analyze the question not asked, but if they ask di by dt 0 plus. So how do you analyze? 2 equal to is 2 integral 0 plus 2 t equal to 0 plus then I of t dt plus I prime 0 plus I0. So in this 2 is equal to 0 plus 2 0 plus, this is anyway 0. I prime 0 plus we want to answer. What is I0 plus? Already got 2. So 2 cancel. I prime 0 plus equal to 0. So this is answer. If they are asking I double prime, differentiate this equation again and again, like that we can work out. So in addition to this, we also answered I prime 0. We got it 0. This is the I. We also answered this. So like this problem can be handled. So this is another problem, little bit important and interesting. Di by dt 0 plus. Di by dt. I is already marked here. Here u of minus t mentioned. U of minus t is a current source. Current source value is u of minus t. And resistor is there, inductor is there, capacitor is there. Here current I. Now is asking di by dt 0 plus. Now at 0 minus, first to draw as usual. Draw the equivalent at t equal to 0 minus. 0 minus is always steady state. So steady state capacitor open. Steady state inductor short. And u of minus t na, means it is present. At 0 minus, current source is there. This value of 1 ampere. U of minus t is like this. So this is U of minus. So 100 ohms. And always what we find here, capacitor means Vc0 minus. Inductor we find IL0 minus. So this is 1 ampere means what is IL0 minus? Looking at this circuit. IL0 minus equal to 1 ampere. What is Vc0 minus is started positive, go to negative. 100 into 1, 100 volts. Here anyway 0. So 100 into 1 equal to 100 volts. So we got this. Next 0 plus. 0 plus, what will happen to current source? Current source value is 0. Current 0 means open. So after this is open, only this circuit is remain at 0 plus. But what is the question is di by dt. So whenever they are asking first order derivative, second order derivative, or third order, compulsorily we have to form one time domain equation. Otherwise you can't find. But time domain equation at 0 plus. 0 plus current source 0 means open. After this is open, this is only remaining. Now write a mesh equation in this loop. So that equation, understand how I am writing. So that is nothing but this looping. So if I started here 100i, 100, sometimes I write I or IT. So I means I of t only. Plus LDI by dt. What is L value? 0.5 di by dt. Okay, plus. Now here 1 by c integral I dt. What is the formula? Basic actual formula is 1 by c, as I said, 1 by c integral minus infinite to t na, minus infinite to t I of t dt is equal to 0. That is a basic equation. Now 100 I of t 0.5 di by dt. This I split like 1 by c integral minus infinite to 0 minus I of t dt. Then 0 minus to 0 plus, that is anyway 0. 1 by c integral 0 plus 2t I of t dt is equal to 0. What is the meaning of this one? This is initial value, na? So what is the initial value we have? 100 volts. Therefore, 100 I of t 0.5 I prime t. This is 100, but this 100, how do you take it? How do you take it? This capacitor already charged with what polarity? This side positive, this side negative. When I am writing mesh equation, we are going from minus to plus, na? Minus to plus, na? Therefore, this you have to take it as this you have to write it as minus 100. So this value is 100, but going from negative to positive, minus 100 plus 1 by c. What is the c value given? 40 micro. So this is 40 micro. Now 0 plus 2t I of t d equal to 0. So this is important. We take minus or plus. So what is the question here? Di by dt, na? So di by dt term already there here. No need to differentiate further. No need to differentiate further. Simplify this. At t equal to 0 plus. Therefore, at t equal to 0 plus 100 into I0 plus 0.5 I prime 0 plus minus 100. 0 plus to 0 plus, this is anyway 0, na? So equal to 0. So what we need here? I0 plus. What is I0 plus? What is I0 plus? So 0 plus inductor is replaced with a current source. This inductor replaced with a current source. So what is the IL0 minus we got? We got already IL0 minus of 1 ampere. At 0 minus, current flowing through this inductor is 1 ampere. Sudden change of current in inductor is not allowed. Therefore, I0 plus also same. So 1 ampere. Therefore, this is 100 into 1 plus 0.5 I prime 0 plus minus 100 equal to 0. So this cancel. Therefore, I prime 0 plus equal to 0. This is the answer. So I hope understand everyone. So di by dt 0 plus we got it. Don't do this blunder. I0 plus is 1 ampere. I differentiate that, I will get 0. Accidentally answer is matching, but always it will not match. And you have to form a differential equation and simplify. Otherwise, it is going to be a mistake. So be careful. So writing this equation is important. Be careful. So there are some more small problems are there already solved. To save the time, let me go through quickly. Okay. So let us start understanding this. So this problem Vs 0 plus. Vs is voltage across switch, is asking at 0 plus. So because asking at 0 plus, you draw the equivalent circuit at 0 minus. And V is there, 0 minus, switch open at 0 na? So 0 minus closed. 0 minus closed. Resistor R1 and 0 minus steady state, capacitor is open, inductor is short, then R2. So this is open. Now look at this. V by R2 current will come. What is I0 minus? I0 minus is V by R2. So this is simple. Similarly, at t equal to 0 plus which is open, then R1 as usual, capacitor replaced with a voltage source whose value is 0. Why 0? When switch is closed, even though capacitor is open, it cannot charge. The voltage in this capacitor is 0. So same thing, 0 I am writing. Then inductor replaced with current source of V by R2. Then this R2 as this. Now, what is this V by R2 path? This V by R2 going through R2, going through V, again going through R1. So what is the current in this loop? Compulsory V by R2. But what we want, Vs0 plus. So Vs0 plus is equal to, started positive go to negative, R1 into current. What is the current in R1? V by R2. Resistance R1. This is the answer. The question is same, Vs0 plus. Then another question, these are all small questions. All these are already asked in some competitive examinations. You have to solve in 1 minute or 1.5 minutes. In this, find IL0 plus. IL is current here. IL 0 plus. So because they are asking 0 plus, draw the equivalent circuit at 0 minus. So 12 volts as usual, 4 as usual, 2 ohms, 2 amps as usual, 0 minus which you closed, resistance of 10 ohm, and this inductor is short circuited. And inductor what we find? IL0 minus. Now looking at this circuit, what is the IL0 minus answer? So this path is short circuit now. As this path is short circuit, current will not flow through 10 ohm. And this is giving 2 ampere current plus 12 by 4. 12 by 4 is 3. So 3 and 2 both are added. 2 plus 3 equal to 5 amps. IL0 minus 5, IL0 plus also 5. That is a question. IL0 plus is asked. So this 2 plus 3, 5, carefully understand. Carefully understand. Otherwise, use superposition principle. Find out, you will get same answer. There is another question. Many students will do blunder here. What is asking? I1 infinite to I2 infinite. I1, I2 are the currents through two inductors. 4 Henry, 2 Henry, both are in parallel. And switch K closed at t equal to 0. I1 infinite, I2 infinite is asking. So infinite means steady state, na? Infinite means steady state. So steady state, if you draw equivalent circuit here at 0, infinite na is asking. Infinite means switch is closed. So 5 ohm. Then this inductor is short. This inductor also short. And here voltage of 10. Here switch closed. 5 ohms. This current is asking. This is I2 infinite. This is I1 infinite. So common mistake in this problem is this is short now. So 10 by 5. 10 by 5, what is the incoming current? 10 by 5 is 2 amps. So 2 amps current entering. So here 2 amps entering. This is short. This is short. Many students will give answer. This current is 1 ampere. This current is 1 ampere. 1 plus 1 is 2. Or some students think that first this is shorted. Na? The whole current will go through here. This is 2. This is 0. So this is a mistake. This is a mistake. Some students 2 2. This is an horrible mistake. So like that different. But what we have to do? Both are short circuit, but actually inductors are there. Inductors are physically present. Then what we have to use? Current division formula between these two inductors. So what is the current division formula? I is equal to psi by L, na? Psi by L. How they are related, inverse relation. So current I1 infinite is 2 into opposite branch, 2 Henry. 2 into 2 by 4 plus 2, 6. So you will get 2 by 3. Then I2 infinite 2 into opposite 4 by 6, 4 by 10. So 2 by 3 plus 4 by 3, if you add, compulsory you will get a 2 amps. So this is a current division formulas we have already done in DC analysis, beginning basics, current division between two inductors. The same concept here. This is another small problem. 40T given, 40T. The source value changing with time. So 10 ohm, 5 Henry parallel. This I is given. And IL0 minus given already. IL0 minus 5 amps given. Okay, IL. So this is the IL. 0 minus given. Is asking I of t at t equal to 2 seconds. I is this. I is this. So I of t at t equal to 2 seconds. This I is nothing but current flowing through resistor, current flowing through inductor. Na? Therefore, I of t is equal to what is the current through resistor? Voltage by resistor. But what is voltage? Vs. Vs is 40T. Na? So 40 into, or otherwise I will write one more equation. I of t 40T by 10 plus what is current flowing through inductor? 1 by L. Current flowing through inductor 1 by L integral minus infinite to t and 40T dt. Vs na V of t. So 40T dt is the basic equation. But minus infinite to t is split into minus infinite to 0. That is initial value. So initial value taken care as 5 amps. 1 by L. L is 5 Henry. So 1 by 5. 0 to at what time is asking? I of t at t equal to 2. So we want answer at t equal to 2 only. Therefore 0 to 2 40T dt. And here 40T na, this t is replaced with what? 2. So 40 into 2 by 10 plus initial value plus 1 by 5, that is 1 by L, integral 0 to 2 V of t. What is V of t? 40T dt. So this integrate, you will get 29 amps. Okay. So, so all this already solved, so that we can save the time. I can cover a little bit fast. Then look at this problem. These are all small differences are there. If you are really able to understand all these problems after I am solving, you are really great. You are above, very much above, very much above average student, because you are understanding after I am solving. So there is a scope to improve further. Without my help, if you are solving on your own, you are superb. you're an IIT student. After I am solving, you are understanding, great. So like based on that, further you can understand, further you can develop. Okay. So this Vs is 10 plus 20 u of t, 20 u of. That means 0 minus 10 is applied, 0 plus 10 plus 20, 30 is applied indirectly. And what is asking? IL0 plus VC0 plus asking. Because they are asking 0 plus, so draw the equivalent circuit at 0 minus. But 0 minus, what is the source applied to 10? Inductor short circuit, capacitor open. Okay. Now, what is IL0 minus? 10 by 50, na? This is the loop closed. 10 by 50. So 10 by 50 is 1 by 5. 10 by 50 is 1 by 5. What is VC0 minus? This side positive, this side negative. So started positive, go to negative. That is 50 into current. 50 into current. Distance 50, how much current flowing? 1 by 5. So 5 1 ja 10. We got 10. VC0 minus. What is IL0 plus? Same na? 1 by 5 is 0.2. What is VC0 plus? Also same na? 10. That's what he is asking. IL0 plus VC0 plus. Done. So 0 minus we got, 0 plus also same. This is another problem asked in DRDL exam. DRDO or DRDL defense exam long ago. In this problem, they asked this bit. This VB infinite, they asked. This problem, this they asked. But for understanding, I also answered some more questions. Problem is simple. So C1, C2, two capacitors are there, inductor is there, R1, R2, here VA, here VB. Okay, switch closed at T equal to 0. So 0 minus switch is open. Na? When switch is open, what is voltage in C1? 0. What is voltage in C2? 0. What is current through inductor? 0. So straight away I am drawing equivalent circuit at 0 plus. 0 plus switch closed. C1 replaced with voltage source of 0 volt. Capacitor C2 replaced with voltage source of 0 volt. Inductor replaced with a current source of 0 amps. Right? Now you can answer these things. VC1 0 minus anyway 0. Then VC2 0 minus 0. Then IL0 minus 0. VA0 minus 0. VA0 minus 0 minus na 0 minus 0 minus it is open. Okay. So inductor is short na 0 minus. Switch is open, but inductor short. So what is VA0 minus? 0. VB0 minus also 0. Is VB0 minus. So currents are not flowing in the circuit. So VB0 minus also 0. Now V 0 plus. VC1 0 minus VC1 0 plus C. Then VC2 0 minus VC2 0 plus C. Next. IL0 minus IL0 plus C. This is same. Next. VA0 plus. VA0 plus important. VA0 plus. So VA0 plus. Start here, go to ground. Go to ground, but you can't go via current source. You have to go like this. And this voltage is 0. This voltage is V. Therefore, VA0 plus is V. Next, VB0 plus. You start here, again go like this. Again go like this. So here 0 volt, here 0 volt, here V. So what is the total value? VB0 plus also V. Next, at t equal to infinite. This is the equivalent circuit at t equal to infinite. Infinite V is applied, switch closed, and this capacitor open, this capacitor open, this inductor short. Okay. Now what we want? What we want? VC1 infinite. VC1 infinite. VC1 infinite again started positive, go to negative. What you get? This is 0, V and voltage in inductor is 0. So compulsorily this will be, so what you get? V only, na? This is V, V and 0, V. So VC1 infinite. VC1 infinite is next to VC2 infinite. VC2 infinite. This one. This is confusing. Plus minus. If you start here, go to negative. You can go this way or this way, no problem. But the point here is, you should know voltage here also. What is the voltage here? This V dividing between R1 and R2, na? This V dividing between R1 and R2. So what is the voltage here? V into R2 by R1 plus R2. V into R2 by R1 plus R2 is the voltage in R2, because this path is open, this path is open. This is only loop closed, R1, R2 are series. Use voltage division, you get this. Now VB infinite done, but VC2 infinite. So start at positive, go to negative. And this voltage anyway 0. This voltage anyway 0. But here you are going from minus to plus, na? Going from minus to plus. So look at again. Here 0. Here you are going from minus to plus. Minus to plus means minus, na? Therefore, what is VC2 infinite? Therefore, VC2 infinite is this. Minus V into R2 by R1 plus. This is the bit asked in DRDO. So just for understanding, all other things also I analyzed. So in all bits which is tough, VC2 infinite is tough. To know VC2 infinite, what we should know? VB infinite, this voltage. Okay. So some additional information also given like this. You can solve. So I1, this is another problem. Switch closed at t equal to 0. Switch K closed at t equal to 0. This branch contain inductor. There is a capacitor. Here current I1. He is asking I1 0 minus, VC 0 minus, di1 by dt 0 plus, I1 0 plus, VC 0 plus. So let us analyze this. Now at t equal to 0 minus, switch open, then inductor short, capacitor open. So remember, there is a capacitor, physically there is an inductor. What is this current? I1 0 minus. So this is the voltage. How to solve this? Here which loop is closed? This loop is closed, na? This loop is closed. 100 by 20 plus 20. 100 by 20 plus 20, 40. So 2.5. What is VC 0 minus? Again started positive, go to negative. Drop in this 20 ohm 0 anyway. Then 20 into 2.5. So you got this 50 volts. Resistance 20. What is the current in that? 2.5. So you will get 50. That is VC0 minus. VC0 minus VC0 plus same na. So what is VC0 plus answer? 50. What is I10 plus? Same, 2.5. Like that. Next, di1 by dt is important. So for di1 by dt, we should form time domain differential equation at t equal to 0 plus. So at t equal to 0 plus, after switch closed, now draw this mesh equation. Draw this mesh equation. So what is that mesh equation? 100 is equal to 20 into I1 of t. 20 into I1 of t plus L di1 by dt. As I said, we are writing mesh equation like this. This is the loop equation. So 100 is equal to, this is short anyway, 20 into I1 of t plus L di by dt. L is 1 Henry, na? So 1 di by dt. Now we want to di1 by dt 0 plus 100 minus 20 into I1 0 plus. I1 0 plus already 2.5. Substitute, you will get the answer. Simple. This is one little bit trickish. Is asking tau. Is asking tau of course after switch closed. What is the tau formula when single capacitor, multiple resistors are there? Tau is equal to R equivalent into C. So what is the C value given? 0.5. But you have to find this R equivalent. How to find R equivalent? R equivalent looking from capacitor. And what we should do, voltage source short circuit. So I have drawn the equivalent circuit at t equal to 0 plus. So switch is closed here, 0 plus switch is closed here, and looking from capacitor. So we are finding R equivalent looking from this, looking from capacitor R equivalent, and this voltage source short. So this voltage source short, this switch closed, capacitor open, R equivalent. So finding R equivalent is little bit confusing. So to avoid this confusion, draw or redraw this circuit again. Okay. So if this point is B, this is B na. So there is a 1 ohm across A and B. So 1 ohm across A and B. And this point taken as C. 0.5 across A and C. Across A and C. This one across B and C. B and C. 2 between B and C. This technique I told you in network reduction. Redraw by then so that series parallel will be easily we can analyze. So 1 2 parallel, series with 0.5, parallel with 1. So what is tough in this? R equivalent. So network reduction series parallel is useful in transient analysis, single source problems useful, theorems useful, many places useful. Series parallel concept. So we got R equivalent of 0.538. Simplify tau. So in this just the tau only they asked. Is gate 16. Some problems I put the number, some problems which year it is asked, I don't remember. But they all asked some exam. When I am solving a problem means that is either asked in some exam or some good book, interesting problem. Okay, accordingly I select. No two problems are same. No two problems will give same information. Every problem will give some additional little bit of concept. So if you go through more and more number of problems, your confidence level will increase. But don't go through all ready-made. Somebody is solving, I am listening. Somebody is solving, I am listening. No. When you start solving on your own, then thought process will be improved, understanding level will improve. Because in the exam, whatever problem I am solving, same problem will not come. On your own, how you can think, how you can solve, that is important. So look at this. Assume that the circuit in figure has reached steady state before t equal to 0. Before t equal to 0. When the 3 ohm resistor suddenly burns out. Resistor burns out, resulting open circuit. So in Kalpain, it is open. The current I of t in amps. Where is the current I? In this 2 ohm resistor. Current I of t in amps at t equal to 0 plus. That is the question. Okay, that is the question. So at t equal to 0 minus already steady state reached as per this question. Before t equal to 0, it is reached steady state. So before 0 and 0 minus. Now 12 volts, 1 ohm as it is, 3 farad open, 2 farad open, and this 2 ohm, 3 ohm. Now this is I. Okay. So what we have to find in this? Whenever in capacitor is there, this voltage we have to find. This is voltage in T farad. And this voltage called as voltage in 2 farad. This voltage we can find if you know voltage between these two. But what is voltage across these 2 points? 2 plus 3, 5 na. This path is open. 2 plus 3, 5. 1 ohm, 5 ohm connected in series. So this 12 volts dividing between 5 ohms and 1 ohm. Therefore, 12 into 5 by 5 plus 1, 10 volts. So what is the voltage between this point and this point is 10. This 10 volts dividing between 3 farads and 2 farads. Again use voltage division between 3 farads and 2 farads. That's why those basic fundamentals are very, very important. Voltage division, current division, charge division, flux division. Topic looks easy, simple in the beginning, but repeatedly we use it. If you don't know that, again punishment. So that 10 is dividing between 2 farads and 3 farads. Voltage across 3 farad, 10 into 2 by inverse relation, 10 into 2 by 5, 4 volts. 10 into 3 by 5, 6 volts. Next, at t equal to 0 plus. 0 plus capacitor replaced with voltage source of 4, here voltage source of 6. And 0 plus, this is burnout, na? Open circuit. So open it. So entire circuit as it is. At 0 plus we are doing. What is the question? What is the question? He is asking I of t in amps at t equal to 0 plus. So he is asking I 0 plus. So this is the equivalent circuit at 0 plus. Here capacitors with voltage sources, resistor open. Now analyze this circuit at 0 plus. How to analyze this? So this is open. What is the just a resistive network? This looks like a resistive network. You must be smart to analyze or understand this. What is the voltage here? 4 volts now. And when this is open, how these two are connected? Series. 2 plus 2 is 4. What is the voltage? 4. Then how much is the current here? 4 by 4 na? 4 by 4 is how much? 1 ampere. What is the direction? 1 ampere is this. What is the current here? 1 ampere. But what is asking I0 plus opposite direction? Na? Therefore, minus 1. I0 plus is minus 1. Generally, if conceptually if you are not confident, you will do blunders. So interestingly, where you are weak, they know. Accordingly, they design a question. Accordingly, they design. So like that, answer is -1. Okay. So 20 U of minus T here, source applied, resistor, inductor, resistor, capacitor. Here find IL of T and VC of T. IL of T, VC of T. So voltage applied here is a DC voltage. I mean 20 U of minus T voltage is applied here. So this is one first order, this is another first order. RL series na first order. RC series is another first order. Constant voltage applied here. Is asking IL of T, VC of T. So first order means 0 plus initial value, final value, tau. Then substitute in that equation, you will get the answer. But 0 plus based on 0 minus. So draw the equivalent circuit at T equal to 0 minus. So 0 minus, inductor is short, capacitor is open. Then what is IL 0 minus? 0 minus 20 is there, U of minus T na? So 20 is present. 20 by 1K, 20 milliamps. Then VC0 minus, started positive, go to negative. Drop in 10K 0. Then drop is only in 1K. 1K into 20 amps, 20 milliamps. So 20 milliamps into 1K. So you will get 20 volts. You will get 20 volts. So VC0 minus 20. VC0 plus also 20. IL0 minus 20 milliamps. IL0 plus also 20 milliamps. Again draw the equivalent circuit at T equal to 0 plus. 0 plus what is U of minus T at 0 plus? 0 na? Voltage 0 means short circuit. This is shorted. Inductor with current source. Capacitor with voltage source. So IL0 plus is 20 amps. VC0 plus is 20 volts. Again at T equal to infinite. At T equal to infinite. What is IL infinite is 0. VC infinite is 0. Why? At T equal to infinite. At T equal to infinite, input itself 0 na? Input is 0 and inductor short, and there is a resistor here 1K and capacitor open, again resistor. So any source is there in this circuit? No source. At infinite, what is the current you expect here? 0. What is the voltage you expect here? 0. So at T equal to infinite, all values will become 0 because source is not there. Therefore, IL infinite 0, VC infinite. Then RL circuit tau is L by R. RC circuit tau is R into C. Now IL of T initial final tau, you will get the expression. VC of T also initial final tau, you will get the expression. So VC of T independently a first order equation. IL of T is also independently a first order equation. But if there is a resistor here, then whole circuit becomes second order. Here, even though inductor capacitors are there and directly a DC voltage is connected across, therefore individually works like a first order. But if there is a resistor in series, the overall problem becomes second order. Then you can't use shortcut method. That is the specialty of this model. This is asked in gate 17. Switch S1 was closed and S2 was open for a very long time. At T equal to 0, S1 is open. S2 is closed. The voltage across the capacitor in volt at t equal to 5 microseconds. So first S1 closed at t equal to 0 minus S1 closed, S2 open. Okay. So VC1 0 minus. Or you can, if unable to understand this step, draw. S1 is closed, S2 open. So this is open. Sorry. This switch open. Resistor, resistor, and steady state anyway, capacitor. And this is closed. So 3 volts, 1 ohm, 2 ohm, 1 volt. This voltage is VC0 minus. So what is VC0 minus? Straight away 1 volt only, na? Started positive, go to negative. How much you get? 1 volt. So VC0 minus is 1 volt. VC0 plus also 1 volt. Now what is asking V voltage across capacitor at T equal to 5 micro. To know 5 micro, you should get complete expression. Total expression we should know. Now infinite. Initial value is 1. Final value we have to find. So what is final value? Final value when S2 is closed, S1 is open. Or again you can draw equivalent circuit at T equal to infinite. T equal to infinite, switch closed. And this capacitor open. And this switch is open. No use of this source. So this is VC infinite. 1 ohm, 2 ohm. Here 3 volts are there. So what is the VC infinite can be? This voltage is nothing but voltage across 2 ohm. Na? So 3 is dividing between, this 3 dividing between 1 ohm and 2 ohm. So 3 into 2 by 3. 3 into 2 by 3 is 2 volts. So final voltage is 2 volts. And RC, so this voltage source short, 2 1 parallel, so 2 by 3, 10 microfarad. Resistance is 2 by 3, capacity is 10 micro, you will get time constant. Now what is the VC expression? Final plus initial minus final e power minus t by tau. Using this formula, simplify, you got this. What is asking? VC at t equal to 5 microseconds. So this t replaced with 5 micro, simplify, you get this. A transient is a beautiful topic. Thought process, lot of understanding is involved. It is not just a procedure oriented, a little bit of logic oriented. Many students afraid of transient, but after you go through all these problems, it will be easy. So what is given? A differential equation is given. A differential equation given. Find the impulse response. So ABCD options also given. Find the impulse response. When he's asking impulse response means what is x of t? X of t is input. X of t is a input, but what is the input here? Impulse. What is Laplace of impulse function? What is Laplace transform is 1. Okay. So anyway, solution. Apply Laplace transform to this. Go for the, is asking impulse response. Impulse response means h of t is asking. H of t is nothing but L inverse of h of s. H of s is nothing but a transfer function. Transfer function is nothing but ratio of Laplace transform of output by input. Ratio of Laplace transform output by input. What is output is y, what is input is x. Apply Laplace transform, take the ratio, you get this. What is this called as a transfer function h of s? What is asking? Impulse response. Inverse Laplace transform of this is nothing but impulse response. So what is the Laplace of this? S square y of s plus 7s into y of s plus 10y of s is equal to 4 into x of s plus 5s into x of s. When you are finding transfer functions, remember initial conditions by default 0. Transfer function means initial conditions by default 0. So don't take here initial value, then think of initial value not given, not like that. Given or not given, by default, you should take it as 0. So this you have to solve using Laplace, using partial fractions. Partial fractions. So a by s plus 5, b by s plus 2. This you have done already, I am not explaining. Find a and b, then inverse of that, you get this. Okay. So just to go through it, h of t, got it. Okay. There is one small b value. Yeah. The specialty of this is 4 by s plus 5 s plus 2 is one function. 5s by s plus 5 s plus 2 is another function. So first what we have done, 4 by s plus 5 s plus 2 done. Inverse of that is this. So this is done. Straightforward. But remaining term is what? 5s by s plus 5 s plus 2. Na? This one you can manipulate 5 by 4, 4 cancel. So like this I am taking. Why I am taking like this is Laplace of df by dt. Laplace of df by dt is nothing but s into f of s. This is using a time differentiation property. Laplace of df by dt is s into f of s. Okay. Now this is how this is looking like. How this is looking like s into s function is multiplied with 4 by some function. Na? So 4 by this already done. That is multiplied with s. So what is inverse of this one? A df by dt. So Laplace of df by dt is s into f of s. Therefore, 5 by 4 as it is d by dt of the time domain function. What is the time domain function is this? So that you write it again. This inverse already done now here. That you write it, differentiate. So that time is saved. Then add both the terms. You will get this answer. This is 7. 7 e power minus 5t minus 2 e power minus 2t. So let me go through this and then stop it. A series RLC circuit has R equal to 250, L equal to 10 milli, C 100 microfarad is asked in IS. assume zero initial conditions, use Laplace transform to determine natural current. Natural current means in the absence of input for a unit impulse voltage input. We said using Laplace. So write a time domain equation, apply Laplace. Laplace of impulse is 1 R into I of S plus SL I of S plus I of S by C of S. Zero initial conditions, na? So they become zero. Then I of S, numericals given, RLC numericals given. Then you get this second order. The second order S square, S into something, na? Roots you have to find quadratic equation. So little bit time is there. S1 minus 40, S2 is minus 25 into 10 power 3. You got it. Then right here, use partial fractions, find A and B given, then inverse. Concept is simple. IS generally conventional type, na, it looks like a BTech problems. BTech problems. So carefully keep on solving equation and time factor is involved. So time will be given like a essay type questions. How you solve in BTech? In the same way, IS questions will be there. So with this, here I will stop now.